Okay, simplify. Rationalize the denominator in each expression. Now, one of those spaces we keep crossing out down here. Now that's going to be in play. So know your radicals. They're both 2's. Nice. So we can just make a half power. Now you can't really simplify anything. It's just x over 2. So I have base x on top, base 2 on bottom. So both to the 1, so distribute 1, they both go to the 1/2 power. Now, we don't need this, you're not going to run across negative exponents. Okay. Alright, so circle your exponents, none of them are whole on top, and none of them are whole on bottom. Now we want to circle the bottoms and see if we can cross cancel them right here. Look on your 2 list, x isn't there, neither's 2. Remember? So, nope, nothing doing there. Now, we need to use this line. I'm explaining why. This bottom number cannot appear on the bottom. You cannot have a fraction exponent on the bottom. Why? Ask the math Nazis. Or did I say that on camera? That's fine. Okay. You have to do what's called rationalize a denominator. Just put RAT. Here's how you do that. You just put everything down. Put your top, your top, it doesn't matter. Okay, it doesn't matter if you have that on top, never has. Now the bottom, you put your base 2 to the 1/2 power. Now you're going to get rid of that bottom. You're going to times by another base 2 with a 2 in the denominator. And to find the top, you simply take 2 minus 1. 2 minus 1 is 1. Okay. Now, so I brought in this second one. When you multiply it on the bottom, you also have to multiply it to the top. Okay. Now, here's why we did that. Because these are both base 2. A half and a half makes a whole. Okay. So this is now 2 to the full first power. Okay. But you got to bring it on top too. Okay. Now, so you're still going to be circling the bottoms. Okay. Now your whole exponent 2 to the first, that just goes here. Now we don't want any radicals on the bottom. Now these both have a 2, so we're able to make a radical of a 2, and then inside we have x to the first times 2 to the first. Okay. Now simplify. On the bottom, 2 to the first is 2. Now outside, you just have your radical. You put the variable in there. You can just write it as x or keep the 1. I don't care. Then the square root, we got to find 2 to the first. Okay, I'm going to circle that. 2 to the first should just be 2. Now you can make your 2 square roots, but the problem is 2's too small to divide. So what I do with the 2 is just leave it in there. And no, these do not cancel because one's in a radical, one's not. Alright, next one. Put 2's in. Okay. So you have a 1/2 power. Now, 5 divided by 8 doesn't divide. It's a decimal, so no decimals. It also, you can't reduce it, so I keep it 5 over 8. And the variable x, nothing to cancel, so it's x. So I have a base 5, and on bottom we have 8 times x. Okay. Okay, now let's talk about 5. Okay. So 5 to the first power. So 1 times 1/2 is 1/2. 1 times 1/2 is 1/2. 1 times 1/2 is 1/2. Okay, now, any whole exponents? No, they're all fractions. So we put them all down, circle the bottom while you do, and see if any of those can go away just by looking at your list. Slash out's what I call it. 5's not in the 2, 8 is not in the 2, and x certainly isn't in the 2. So we're not able to get rid of any of them. But there's still these on bottom. Put RAT, RAT. You put, now, so you got to use this line now. You can't have those bottoms be fractions. So 5 to the 1/2, okay. Then I put an 8 to its half power, but then I need to rationalize that by timesing by an 8. 2 minus 1 is 1. Okay, now you got to do that on top. That's good. Now you got another one you have to rationalize. You have your base x to the 1/2 power. So we want to circle that over 2. The denominators should be the same, and then 2 minus 1 is 1. And then you got to take that second one to the top, because if you bring it as a factor on bottom, you got to bring it on top. Now, you can cross that out. That's now 8 to the first, and that's now x to the first. So those are now whole on bottom, which is the point. So 8 to the 1 times x to the 1. Now you still got these bottom buggers here. They're all the same, so just one radical with a 2. So you have 5 to the 1 times 8 to the 1 times x to the 1. Okay. All right, now outside you're going to have 8, and you can keep it x to the 1. Now in your radical, you're going to put the variable x to the 1. Now in the radical, take your calculator quick and find what 8, it's just 5 times 8, okay? You're going to want to multiply those two. The variable I just placed over here, but 5 times 8, they're both to the 1, so it's just 5 times 8 is 40. Now break it down, or at least try to. You're on your 2 list. So 40 divided by 36 decimal, 40 divided by 25 decimal, 40 divided by 16 decimal, decimal, okay, 4 and 10. So remember how this works. That becomes 2, and then 2 in front, 10 inside. Now that can work as your final answer. You could reduce the 2/8 to 1/4. You don't reduce with the inside the radical. Okay, I'm not going to really require you to reduce. Now how about some cubed roots? Not much you can do with x over 2. So you have x and 2. So they're both to the 1/3. No negatives. So you put x over 2. They're all fractions. You don't have any whole exponents at this juncture. Okay. Now circle those bottoms. Look on your 3 list. X isn't going to be there, and 2 is not either. Okay. So we cannot slash out. Can't get rid of it the quick way. But we do have a bottom. You need to put RAT if you have that on bottom. Circling the bottom will help highlight that. Okay, at the top you just write down. Okay, you should write down the top. Now write your 2 to the 1/3 power. But you have to rationalize that, so you're going to times by a 2. 3 minus 1 is 2. So you don't just copy it. Yeah, half you copy it because 2 minus 1 is 1. But what's 3 minus 1? It's 2. So I'm timesing up here by 2 to the 2/3 power. Now 1/3 and 2/3 makes 1 whole. Okay. So that's why you got to just put the base, same bottom, but to find the top you minus what's on the original. And you got to remember to also times by that on top. So now we have 2 to the first, no more bottom. These still have a bottom, they're both 3s. So I make a cubed root. You're going to have x to the 1 and 2 to the 2. So on the outside, 2 to the first is 2. So I make my radical, always put the variable inside. You can put x to the 1 if you want. But inside, we've still got that 2 to the second. Well, 2 to the second's 4, so that's what I'm simplifying is 4, okay? 2 caret 2 is 4. Okay, cubed root, 4's not there, or, well, 4, it's too small, so what I do is I just keep the 4 inside the radical. Nothing comes out. Okay, there's your answer. Okay, next, 1/3 power, So 5 divided by 3 doesn't work. It's not reducible. And then you still got the x factor. So you got a base 5, and then you got a 3 times an x. So 1 times 1/3 is 1/3. 1 times 1/3 is 1/3. 1 times 1/3 is 1/3. Okay. Now, circle your powers. There's no whole ones, so we just bring them all over here. Remember, be circling the bottoms. Okay, can you get rid of any of the bottoms a quick way? Well, you're on 3s. 5 ain't there, neither's 3, neither's x. So no slash out. But you got to rationalize when you have those bottoms on the bottom, okay? Okay, so 5 to the 1/3 power I just dropped. Now, that has to be rationalized. So I go 3 to the 1/3 power times 3. What's 3 minus 1 is 2. Then you got to remember to times it to the top, okay? Then we have another one, x, okay? To the 1/3 power times x. 3 minus 2, 1 is 2. Now this now becomes 3 to the 1st power, and this now becomes base x to the 1 power, because if you add those powers, it's 1. If you add those powers, it's 1. Okay, now, so 3 to the 1 and x to the 1. I'll circle all those bottoms, and they're all the same, so I make a cubed root. So 5 to the 1st times 3 to the 2nd times x to the 2nd. Okay. Once you make that root, now the bottoms are gone. That's what you put inside, is that stuff right there. So outside you're going to have 3 times x. Now you make your radical, put the variable factor, and then here I simplify. It's real simple. You just go 5 to the 1st times 3 to the 2nd, 45. Okay, now you try to break it down. You're looking at the 3 list. Look at the right list. So 45 divided by 27, nope. Divided by 8, nope. I guess we're leaving it. Okay. Okay, next problem. These are square roots, okay? Now you need to do some simplifying on the division here. Now 5 divided by 2 is a decimal, and so it'd just be 5 over 2. Okay, now we got x on top, bottom. Get rid of the smaller one. So it's a 2. So it'd be x2 on top, and then y1, y3. It's y2, but it's on bottom. Okay, you need to try to simplify that just like I've showed you in the past. So the top you got 5 times x, bottom you have 2 times y. So on the 5, 1 times 1/2 is 1/2. On the x, 2 times 1/2 is 1. 1 times 1/2 is 1/2 on the 2. 2 times 1/2 is 1. Use a calculator. Alright, so put your whole first, then put your fraction, put your rationals. Okay, so circle those bottoms. Look, 2, 5's not going to be there, neither's 2. Okay, so they did not go away, and this one then needs to be rationalized. Okay, we're copied on the top. You don't have to rationalize the top ever, never have had to. Now the whole one we just dropped, we just put. That's why you want to put that first. Now the rationalized one, you have to times by another base of 2 with a denominator of 2 in the rational exponent. 2 minus 1 is 1. Then you got to remember to bring that to the top. A lot of people will forget that. So this now becomes 2 to the 1, because 1/2 plus 1/2 is 1 whole. Just like 1/3 plus 2/3 is 1 whole. Okay, so you got your full ones, x to the 1, y to the 1, 2 to the 1. Now your bottoms that you still have, they're both 2. So you make that root, then you cross out the 2 and you have 5 to the 1 times 2 to the 1. So outside x to the first is x, y to the first is y, 2 to the second is 2. You might want to put the 2 before the y, it doesn't really matter, but yeah. Then your radical, you don't have a variable in there, okay? So you need to multiply 5 times 2. They're just to the first, so it'd just be 10, okay? Okay, see if that breaks down. So 10 divided by 9 decimal, 10 divided by 4 is a decimal, so when that happens, you just keep 10 in the radical, okay? Don't bring it out, okay? There you have it. You can't really cancel the 10 and the 2. One's in a radical, one's not. Okay, next one. 1/3. Now make the line, but see if you can do that. 12 and 10. Okay, now 12 divided by 10 is a decimal, but they have a GCF of 2, so you can divide them by 2. That'd be a 6, that'd be a 5. Okay, 6 over 5. Now the A, 1 and 3, that goes away, and we have minus, and we have a to the 2 on the bottom. The B, 3 and 1, that would go away, and that's a 2, so b to the 2 on top. Then C1 minus 1, that's 1, so c to the 1 on top. Okay. All right, now we're ready to roll. So we have 6 times b times c, and then 5 times a. Okay, so 6, so you got 1. 1 times 1/3 is 1/3. 2 times 1/3 is 2/3. 1 times 1/3 is 1/3. 1 times 1/3 is 1/3. Any times 1 itself. 2 times 2/3 is 2/3. So circle all your powers. You don't have any whole ones, okay? So you just line them up in the order they're in over there. So this is going to be somewhat of a challenge, okay? Okay, 3, you have 6 or 5. You know you don't have any of B, C, or A. How about 6 and 5? No, 6, 5, no. So I got to rationalize here and here. When they're on the bottom, you have to rationalize. So you write down your top, you just copy it down. You might want to extend your line here. Now we start rationalizing. 5 to the 1/3. Don't put 1/3. What's 3 minus 1? It's 2. Yeah, when it's a half, you can copy it, but not thirds. Now you get times by 5 to the 2/3. Go to your next one. A to the 2/3. So times A. What's 3 minus 2? It would be 1. You minus, if you want to find the top, you minus it. Now what that's accomplished is now I have 5 to the 1 whole and a to the 1 whole. So 5 to the 1 times a to the 1. Now unfortunately on top, still got all those, but fortunately they're the same thing, okay? Now I would probably be smart about how I did this. I would put the 6 to the first and the 5 to the second together, because those are both your numbers. Then all my letters, doesn't matter the order of the letters, b to the second, because all these 3's are gone. I would do the number basis first, then variables. B second, C1, and A1. So outside you got 5 times A. Now you make your radical 3, put all the variables in. B, give yourself some room, because you might have to number in there still. And then C to the first, and A to the first. Now, we need to simplify that little part. So 6 to the 1, I mean, you can go like that. If you want to use your calculator, it's 150. 6 times 25. Now, try to break it up. So you're on your 3 list. So 150 divided by 125 is a no-go. No go, no go, no go. That's not a bad thing, means you get to just keep 150 inside, and that's simplified. Alright, this one here is going to go pretty quick. Can't do anything with 2/5. You can't divide it, you can't reduce it. There's the GCF's 1. Okay. So you have a 2 and a 5. Both would be to the 1/4. So you don't have any holes on top or bottom. Circle the bottoms in. Are those under 4s? Not even close. 2 and 5, no. So that means we have a bottom, we have to rationalize it. If that wasn't on the bottom, if I didn't have that number and that rational exponent on bottom, I'd be crossing it out. Now, what's 4 minus 1? It would be 3. You got to also remember to multiply that on top, because you brought in a new factor on bottom, you got to bring it to the top. So 1/4 and 3/4 makes 1 whole. So 5 to the 1. So 5 to the 1. Now you're able to make a 4th root, 2 to the 1st. That means these are crossed out. Times 5 to the 3rd. 5 to the 1st is 5. Now you make your radical. You don't have a variable inside. So you find what the heck it is you're simplifying by taking the 2 to the 1st, or 2, times your 5 to the 3rd. 250. See if that's possible. You got to be on the 4s now. So 250 divided by 81 decimal. 16 decimals, you know what that means. You just leave it. The 4th root of 250 over 5. Okay, finally we're to the last one. 3/5, nope, nothing you can do with that. Now the x's are both 1s, get them out of there. Okay, completely. Minus 2, you're still going to have a y to the 1 on the bottom. Okay. So you have a 3 and then a 5 times a y. So 1 times a half is 1/2. 1 times a half is 1/2. 1 times 1/2 is 1/2. Alright, now, so you don't have any whole exponents to bring over, so they're all rational. Okay, I don't think you can slash out any of them. They're never, the 3's not on the 2 list, neither's 5. By the way, I'm not looking at that number. I'm looking at the numbers in the radicals. No. Okay, so no slash out, but you have to rationalize these. Okay. So bring your 3.5 down here. Now you're going to rationalize the 5 to the half. 2 minus 1 is 1. It's going to be over 2 still. That's 1. And the same thing. Whatever that second one is gets copied to the top. Then y. Okay. It's 1. And you got to copy that second one to the top, because you're bringing in a 5 to the half, y to the half that wasn't there, so it's got to be also brought up here. So that's now 5 to the full first times y to the full 1. So we have 5 to the 1 times y to the 1. And all those are 2's. Okay. So they're all canceled. 3 to the 1 times 5 to the 1 times y to the 1. Okay, so we got 5 times y on bottom. I mean, with the 1's we can drop them. Now in the radical, y to the first would just be y. And then 3 to the 1 times 5 to the 1 is just 3 times 5, that's 15. Then break it up if possible. 15 divided by 9 is a decimal, divided by 4 is a decimal, so you're keeping it at 15. Okay, number 1, you can start off both 2's, but you can reduce the 8 and the 6 into 4 and 3.